Okay, vectors and forces. So we can bring in some of the work we've been doing in mechanics into the work we've been doing with vectors. So we just do a quick start on that now. So e.g. we've got an object with 3 forces acting on it. And we've got F1, F2, and F3. So F3 has magnitude 10 and is making an angle of 60 degrees with that positive x direction. F2 magnitude 12, and this really isn't to scale. F1 magnitude 50, and we want to find the resultant force. So we've been working with finding the resultant force horizontally and finding the resultant force vertically, and some of you will have been looking at finding the resultant force on a slope. But this really is doing the kind of horizontal and vertical in one go using vectors. So this force F1 in vector form, we can write that as 0 minus 50. So we're looking for these 2 perpendicular directions again. And F2 is going to be minus 12, 0. And then F3 is equal to, so this is the result of doing this x component plus the y component. So it's resolving forces again. To find this bit that's acting horizontally, we want the adjacent to the angle. So this is 10 cos 60. If you're in any way unsure about that, if you call that x, then cos of 60 is equal to adjacent over hypotenuse. And so x is 10 cos 60. And then similar for this y component, vertical component, this is opposite the angle. So this time I'm looking for 10 sine 60. Using a calculator, cos 60 is a half. So 10 times a half is 5. And sine 60 is root 3 over 2. So this gives us 5 root 3. So this is 5 in the positive x direction, 5 root 3 in the positive y direction, if you had those on coordinate axes. And then to find the resultant force, you literally just add the forces together. So horizontally, I'll write them down again. So 0 minus 50 plus, sorry, that's minus 12 there. I think I said minus 12, like 12. Minus 12, 0 plus 5 root 3. So yeah, 12 acting that way, so it's definitely a negative 12. And then, so horizontally, the resultant force is minus 12 plus 5, which is minus 7. And you know that because this is 5 going this way, 12 going this way. So it's no different to what you've been doing, we're just writing it in vector form. And then vertically, we've got minus 50 plus 5 root 3, which gives you negative 41.3. or you could leave that in exact form if you wanted to. So resultant force, add your vectors together, and then showing that on a diagram. I'm okay to turn it over, I've got it in front of me. So on a diagram, we have got F1, which is acting down minus 50. I'll try and get my scale slightly better. And then we've got F2, which is minus 12. And then we've got F3, which was 5 root 3, so that's coming up there, like that. So the result of all these three forces acting together, you put them end to end when you add vectors together. And the resultant force is this one here, which takes you down like so. And so that resultant force is equal to minus 7 minus 41.3. I think I made this clear in my last video, but yeah, when you're adding vectors, so if you've got A going that way, and if you've got B going that way, then to do A plus B, you put your vectors end to end, and then the resultant force will be across here in this case. So I've just popped those vectors end to end to F1 plus F2 plus F3. Apologies if you tried this after my last video, because I think I got my numbering slightly wrong. But page 256, so question 11, that's quite a straightforward resultant force question. And then if you haven't done it, question 12 is a little bit more like the one I've just done. So you have to resolve horizontally and perpendicularly for one of the forces. And then you could have to think through question 14, but that's more of an extension question. But those two are good to do, just thinking about applying this vector work into forces.